All right, welcome back. So hopefully you've already finished example one and you've had a chance to also finish example two, because I had asked you to try this out for yourself first, then watch this video. If you haven't taken a chance to do this work for yourself, please pause this video and then do the work for yourself. Then check in with me to see if we were on the same page or if there might be some things that you need to revise. There are some problems where you'll have multiple options for how to solve it. In this one, there is only one right answer for each part. Actually, there's two right answers for method one and one right answer for method two. And then part C, I'm gonna still leave it up to you even after this video. All right, so to begin with, we're going to annotate. And whenever we annotate, we start by looking for amounts or numbers with words. And so I noticed 35 boys here. And so I'm going to highlight 35 boys with green. Then I noticed the number of girls, and I also noticed 42. And so for you, you're not going to see this all in one box. You're not going to see that in the sixth grade in the same box. That will kind of be in the background. And so you're going to need to highlight the number of girls first, and then the actual number itself. So then that means Lonnie says then that the number of boys in the sixth grade, so I'm going to highlight this entire box, to the number of girls, again, I'm going to highlight the whole box, but you can also select the whole thing and then highlight it, is 5 to 7. Okay, so we have these two different things and we're trying to figure out, is she correct? Is her version a simpler version of the same relationship that's going on with the total number of boys and the total number of girls in the sixth grade? And so we're going to figure this out. So hopefully you've already done this, but if you forgot to annotate, now you can annotate. And you're welcome to pause this video at any point, especially like halfway through or when I finish the section, to make sure that you're not having to remember everything till the very end. All right, so method one says that there are, according to Lonnie, 5 boys for every 7 girls. And so we're going to assume that she is correct, and we're going to figure out what it would take to make her correct. So if she's correct, then these 5 boxes would have to equal 35 boys, and these 7 boxes would have to equal 42 girls. And so step 1 says fill in one of those totals that we already know. So either you're going to put 35 here, or you're going to put 42 here. And it matters in the sense of whichever one you choose, it's going to change everything about what's happening to make sure that it works. So I'm going to choose 35 boys first, and then I'm going to show the alternative to show what would happen if I had chosen the 42. So if I choose 35, then that means these 5 boxes have to equal 35. So 5 times something gives us 35. So count by 5s to yourself in your head or out loud until you get to 35 and tell me how many you get. All right, so hopefully you counted and it was 7 of them. If not, you can recount to make sure that it was 7. And so if it's 7 times 5, then that means the 7 has to go in each of the 5 boxes. So then this is 7, 14, 21, 28, 35, okay? If a 7 is in one box, it must be in all boxes. And so down here, it's also going to be 7. And I have 1, 2, 3, 4, 5, 6, 7 boxes of 7. Well, 7 times 7 is not 42. 7 times 7 is actually 49. And so that's a problem because according to Lonnie, if the ratio is 5 to 7, and that should get us to the same totals if we're able to find the right number. So we could change the number inside the boxes, but that's not, you can't do that. You can't change the numbers so that they're different if they're the same size box. So then let's see what would happen if we put 42 instead. So I'm going to go back and undo each of those pieces, and I'm going to try 42 now. Now, if you did the 35 and you did all that we did, then you don't have to undo. You can keep it as it is. So 7's in every box, 35, and then 49 to show that she is probably incorrect. But let's now check the other way, and you're welcome to do it this way if you'd like instead. So if it's 42, then we have 7 girl boxes holding some amount, each of them the same, to get to 42. So 7 times what will get us 42? Well, I already know that 7 times 5 is 35. So 7 times 6 would be another 7. That makes 42. Okay, so 7 times 6, which means that each of these has to hold a 6 if I want to see a 42 at the end. So this is 6 plus 6 is 12, another 12, another 12. So together that's 36, plus 6 more is 42. Okay, so this works. So then that means these all have to be 6s instead of 7s when we originally looked at it. But 6 plus 6 is 12, 18, 24, 30. This equals 30. Again, that's not what we want to see. We don't want to see a ratio other than 35 to 42 because that's actually what's happening in this school. And so that means that Lonnie must be incorrect according to method 1. Either you have 7s in each box and you get 35 to 49, or you have 6s in each box and you get 30 to 42. Either way, we're not getting the original ratio. All right, so you might want to pause the video for a moment, and then I'm going to pick it up in method 2. Okay, so hopefully you've had some time to fill in your notes, either with 7s in every box and the totals that would come from that, or 6s in each box and the totals that would come from that. I'm going to erase my work there. So now we can look at this fresh and we can see what is it that we need to do in method 2. Method 2 says to create a fraction version of the ratio. So boys was 35 in the word problem, and so girls is 42. So I'm going to put 42 here. The next thing is we need to figure out a number that we can simplify by. And simplifying means that you can count by that number to get to both of these so that we can look for a smaller relationship or smaller numbers in the same relationship. So what's a number that you can count by to get to 35? Well, originally, when we had the 35 here, we had the number 5 and the number 7. So we could use 5 or 7. Don't type this, though. If I use 5, then I have to also be able to count by 5s to get to 42. But you can't get to 42 counting by 5s. 5, 10, 15, 20, 25, 30, 35, 40, not 42. So I can't use 5. So I can only use 7. Now, can we count by 7s to get to 42? Yes, we can. There were 7 boxes here, and originally we had 6 in each box to make it 42. So I can put 7 here, and I need 6 7s to get back to 42. So when you divide 42 by 7, you get 6. Divide 35 by 7, you get 5, because you need 5 of these to get to this. So this is what's called the simplest form, or the simplified ratio. The simplified ratio is 5 to 6, or 5 over 6. Well, that's not the same as what Lonnie said. And so based off of both methods, we can determine that her ratio is incorrect. 1, because it would have gotten us the wrong totals. It wouldn't have been equivalent to the original ratio. And 2, if we start with the original ratio and we simplify, we're not going to end up with 5 to 7. We'll end up with 5 to 6, which is slightly different, and it makes a world of difference in terms of having accuracy. So Lonnie is incorrect, and you can explain based off of either method or both methods, how do we know that she is incorrect? What in the different methods led us to understand that she was incorrect? What would we have expected to see that would let us know that she was correct if that had been the case? So you can do the summary for yourself. And I'm going to undo this and pause the video. Hopefully this was helpful. If you have any questions, please make sure you ask during class time.